Hello Year 7s, welcome back to Maths with Miss Hong. Today we are doing 2E, problems with parallel lines. Alright, so if you have a look at this building here, you can see that, I'm sure you can see that there's lots and lots of parallel wooden blocks here. So you can see that this is a real life application of what you're learning. Parallel lines are very important in buildings, so engineers and builders really need to consider parallel lines and the angles in between them when they're constructing a house like this. So just to clarify, parallel lines, they are two lines, and I told you that they're indicated because they have the same arrow. It could be one arrow, it could be two, all right? And basically they're like train tracks. They never meet. They keep going indefinitely with no endpoint in one direction, and they will never meet each other, okay? All right, so this is a bit of an intro. Can you pause the video and see if you can try and figure out the value of angle A? And just by the way, before you go, just keep in mind that whenever you write an angle, for example, 37 degrees, you always need that little circle. That means degrees. Just like here, I've written angle A degrees, okay? So pause the video, have a go, please. Good job. All right, so let's go through it. We can see here that we've got parallel line 1, parallel line 2, because they've got the two arrows, okay? And then we've got a transversal here cutting through the parallel lines. So if we think back to one of the definitions we learned yesterday, which was corresponding angles. Corresponding angles are in the same position on both of the parallel lines. So we can see that on this parallel line, this angle is 65 degrees. The angle in the same position, so to the left of the other parallel line, is also going to be 65 degrees. Okay, so we know this angle is 65 degrees. We know this angle is a right angle, 90 degrees. And we know that overall, this entire angle is going to be 180 degrees. Okay, so 180 degrees is equal to 65 plus 90 plus our unknown, which is A. So if we add 90 and 65, we get 155 degrees. A bit of simple algebra. We want A by itself. So we're going to move the 155 to the other side. 180 minus 155, that gives you, 25 degrees. So that little angle there is 25 degrees. All right, so that's a bit of introduction to what we're doing today. We're just doing some problem solving with the angle definitions we've been learning about with parallel lines. So just a quick recap, we know that the transversal line is the line that cuts in between at least two other lines. We've got one line here, and then we've got our transversal here. It's cutting in between the other two. And sometimes L1 and L2, the two lines are parallel. That's normally what we'll be dealing with. Okay, alternate angles. So they are on opposite sides of the transversal and inside the other line. So the way that I said to remember this was the Z. Okay, so what that means is, get a different color. This angle here is equal to this angle here, okay? Because they're on opposite sides of the transversal, one on the left, one on the right, and inside the two other lines. All right, corresponding angles. Angles in the same position. The way that you can remember this is the F. The F. Sometimes it'll look like that. Sometimes it'll look like that. But they're all different versions of an F. So if I was to draw in an F here, corresponding angles in the same position, this angle would be equal to that angle because they're both below each line. Sorry, I shouldn't say that they're equal because that only applies in parallel lines, but they are corresponding. Just like how this angle here is corresponding to that angle there because they're both above the two lines, so they're in the same position. And the last angle we learnt about was co-interior angles, and they said the way that you can remember this is a U or a C or a different variation of that, looks like hieroglyphics or something. So let's have a look at our example. Okay, so can you see any C's or U's? I can see a backwards C there. So this angle and that angle are co-interior. Okay, so that's a revision from yesterday. Today, we're going to do some problem solving. Let's look at problem A. Okay, so we can see that we've been given one angle, but we need to figure out what angle A is. Okay, so I wonder if we can figure out what this angle here is. Yes, you're right. It is corresponding to angle ECD. So this is also 75 degrees. And we can see here that the rest of the revolution is angle A. So if we were to add A and 75, that would be equal to 360 degrees, a full revolution. Therefore, angle A must be equal to 360 minus 75, which is, I'll give you a second to do that. Yep, that's it. 285 degrees. All right. So that was using corresponding. Let's have a look at the next example. This one looks a little bit trickier. So always start with what you know. So you can highlight what you know maybe. Let's highlight. We know that this angle is 170 degrees. This angle is 90 degrees. So we can figure out this angle here, right? Because we know that they're all angles, that's a revolution, and we know a full revolution is 360 degrees. So we've got 170 plus 90 plus angle BDE, altogether they're equal to 360 degrees. So if we subtract these from both sides, have a think about what you might get. 360 minus 170 minus 90 is 100 degrees. So this angle here is 100 degrees. 100 degrees, sorry, getting my pen back. Okay, so if this angle is 100 degrees and we've got parallel lines here and a transversal here, this angle, unknown angle A, is corresponding to this angle, angle BDE. And that's because we have the F situation. We've got an F situation. So we've got this angle is equal to that angle. And therefore, angle A, wrong color. Angle A is equal to 100 degrees. Okay, year sevens, you're listening very well. Let's do one final example before I let you do your exercises for today. Actually, we've already done that one. We'll skip over to the next one. Next page. Okay, let's have a look at D. It looks a bit funny. Okay, so I can see, always orientate yourself. So we've got angles that we know. We've got angle 70 there. We've got angle 60 there. This is what we're trying to find out. We've got parallel line 1, parallel line 2. We know that they're parallel because of the arrows. And then we've got a transversal here, line BD. Okay, so what do we know about this? Okay, guys, I think it's time to talk about a different type of angle which we haven't discussed yet in these problems. So remember, when you, is this the F situation, the Z situation, or is it the U situation? There's actually a few ways you can tackle this problem, but the way that immediately jumped out for me was the U situation. I can see a big U here. Okay. All right, so what that means is angle ABC, this angle here, plus angle DCB is equal to 180 degrees. And that's the co-interior rule. Okay? So we know that angle DCB is 70 degrees. They've given us that information. We know that angle ABC, we know that part of it, this part is 60 degrees. but we don't know this part. This part is our unknown. It's our unknown angle. Not to worry, we have enough information to find it. If we subtract these two numbers from the other side, that's 180 minus 130. That is 50 degrees. Okay, guys, there is another way to figure this out. Let me just redraw the situation. Okay, the other way to figure this out is using the Z option, the alternate angles. I can see a Z here, okay? And according to alternate angles in parallel lines are really cool because, okay, so they're on either side of the transversal. So here we've got this angle, angle 60, is going to be equal to this angle, and that's an alternate angle. Okay, the second step is we still need to figure out what our unknown is, our unknown angle. This is where you use the sum of angles in a triangle. I don't know if you've learnt this in year 6. It's okay if you don't know what this is, and you can switch off and do your exercises now, but if you're interested, the interior sum of angles in a triangle always adds up to 180 degrees. So that means angle A plus angle 60, sorry, not angle 60, 60 degrees plus 70 degrees, they're the three angles in the triangle. They add up to 180 degrees. And we can see that this is the exact same as this step here, which we figured out using co-interior angles. This is showing you that there's often multiple ways of figuring out the same problem. So again, we're simply going to subtract 130 from both sides to get 50 degrees, which is what we got when we used the other method, 50 degrees. Okay, boys, this topic is hard, okay? Some of you are going to find this tricky. Remember, I am here online the whole lesson, and you can jump back onto the video chat if you ever video call if you need help, okay? So go back to our lesson instructions and find the set exercises for today. You're doing 2E, and this is the last chapter of our geometry topic. All right, see you later, boys.